Well, that's not quite true, because some people think that something similar to that may be the origin of the rill, namely a collapse feature like a lava tube where the lava is run out of.
Jane, didn't you say something about we were going to have this conversation reproduced, and we were going to repeat questions from the group? But we're not doing that.
Well, we're doing part of it. We are recording it. We've been sloppy about repeating questions, and I'll try to be more faithful in that.
I'm just thinking that, I was just hoping that we're not making a mistake here. It ought to be mentioned if we are.
Well, Doctor, the other alternative is to use that speaker, but with the air ground going, we thought this would be the most effective means.
Yeah.
Having us talk is enough of a distraction.
There are other people listening in, however.
I will try to repeat the questions in the future.
As long as the television sounds
Jim, all our numbers on you look good down here.
No, Ted, actually, this will ultimately be transcribed, and of course it's much easier for the people doing the transcript to have to.
I think it would be interesting during one mission at least to have a monitor sitting beside this monitor that showed the medical data on the astronauts, and have one of the physicians here to tell you what that meant, because I'm ignorant.
When they were horsing around with the rover, it would have been fascinating to see how they were working, how hard they were.
How much effort would it be to set that up for, say, this next EVA? Do you have the physical facilities to get us a second monitor here?
Let me check on it. One thing we certainly can do is remind the accounting so that perhaps during these particular times when there's more effort going into something, to give us some readouts. He has the same problem. He doesn't want to cut in on the air ground, but I'll check on it.
Chuck it like that.
Why?
I know from
Yeah,
last
he's
time,
letting
Gene,
us
we
speak for
can get the
himself
outset
right now.
one so you can see the plasmona. We did this before.
I believe Terry White.
In fact, we could use that second monitor
That's what
over
we were
there.
doing, yeah.
Yeah.
Jack, I know last time we got the outset, we at least the seismometer trenches and so on that second screen. I think you can probably switch to
Check on that. I'll get that.
Yeah.
Once you just go through your EMU number 5, then I'm going to close your flap here. Perfect.
We do see rocks with the textures of rapidly cooled volcanic rocks. We do see outcrops in the bottom of larger craters in the Mare areas. We can, to some degree, on Apollo 12, relate the rocks to the positions where they came out of the crater and actually come up with these ones. Look at those, they were deeper than those ones, so therefore many people believe that we are dealing with volcanic phenomena.
Pardon me, Robin. When I say that I don't refer to it as lava, nevertheless, I regard it as something that possibly flowed out of the interior of the moon, all right. My difficulty with suggesting that it is an ash flow is that we need gas mixed with finely divided material to get it to flow the way ash flows flow on the Earth. And the gas on the Earth is water, and the gas on the case of the moon must be something else. I've tried to think of other gases that might be present, but I don't have any very good suggestion in regard to it. Also, well, carbon dioxide is one that you might think of. Perhaps you could generate hydrogen gas, perhaps the carbon monoxide, things like this.
Calculations showed it'd have to be carbon monoxide and hydrogen if it were, anything at all, or else something inert like argon, which is, of course, is ridiculous.
Argon is not likely at all.
No.
Yes. So, also, I think there is one feature that might supply dust, and that is the big collisional phenomena themselves that would put up an enormous atmosphere of dust and stuff that might fall in some way. This might contribute some too. But I think what we need most of all is some sort of an ash flow mechanism to account for most of what we observe.
Band's back on.
Gentlemen, are you talking about the general formation of most of the stuff we see now, or are you talking about the Mars?
The question is whether we're talking about the general formation of the dust on the moon or about this specific site.
Talking about Mare filling.
The way they skip along is interesting, isn't it? I think it'd be interesting to walk on Earth like that.
If you did it outside here, you'd be locked up for that.
All your numbers look clean as can be down here.
Oh, that's encouraging.
Look at the bird.
Dave, you told me, did you finish with this pallet that's here at Mesa? Oh, yeah, he can do it, but I had to take the pallet out to get the TCU off.
And Dave, you're setting a new outdoor record with each cough there.
Yeah, that's pretty neat, huh? If we won't clutter up the immediate vicinity.
Known as not littering your nest?
Getting back to the Mare on the front side versus the back side,
I'm telling again, but I won't even bother telling you because it's
I think many people would
We can tell when you get a tone down here. We hear it as well.
many people would find it difficult to have capture as late as the filling of the Mare basins, namely 4 to 3 billion years ago. I think this would be a huge stumbling block, particularly to the people who make the calculations, celestial mechanics, regarding capture. The other theory on this business of Mare on the front side versus the back side, I think you can say is a U.S. Geological Survey idea, namely that when the lunar crust was solidifying, due to the Earth's tidal pull, the center of gravity of the moon was displaced, and the crust was thinner on the side facing the Earth than the other side, the back side. This is a very ad hoc argument, I admit. And therefore, when you got the large impacts and fracturing, there was less of a shell to penetrate to release this lava than the other side. I think it's very ad hoc. I don't really think we can say either way, but I'm just giving a second suggestion that has come out.
Two of my colleagues this morning have talked about large stresses on the front side of the moon, meaning the side facing the Earth, due to the tidal pull. I personally don't think this is correct. I guess I'm taking on two people.
I'm with you. Even though I'm one of the people.
I would remind my colleagues that on Earth we see two tides daily. There's one that comes by, and 12 hours later there's another one that comes by.
But that's a resonance phenomenon.
That's not a resonance phenomenon. And if you look at the mathematics of it, it comes out immediately. Now, the tide on the backside, as all of you know, is a little lower than the one on the front side, but nonetheless you do see two tides. And if you go through the gravitational potential for exactly this thing, you find that the one on the backside is only slightly less than the one on the front side. So I don't think that this explanation holds water.
But this,
The moon reflects this, as I understand it now. You have a bulge on the back side, if you have a bulge on the front side. The old idea that you saw a bulge on this side is no longer.
Of course.
Gene, if you put the moon much closer to the Earth than it is now, then you might get a much larger difference between the two. But
Yeah,
one
it's
of the
all,
things-
but it's only due to the gradient, and the radius
right.
of the moon compared with the
That's right.
distance from the Earth is
Yeah.
the thing that counts, and
Yes.
it's
very small.
yeah, it's still going to be small. It
That's
seems to
right.
me, even though you put it right upside the Earth.
But one of the things that the Geological Survey people do systematically, I think, is to pay no attention to the problem of supporting the mascons. They immediately turn on a completely melted earth anytime they want to, and pay no attention to this at all.
They disconnected him.
No, you can see them watching it in motor up on the wall.
There's a time lag in between there and here.
You gotta switch it now to the robot.
I was wondering why they could still be seeing it in motion.
We'll try to say nothing of significance.
No, it's just a TV talk.
Okay, Joe, I'm going to put the TV on the roller now if you're ready. And so far the LCRU is on, locked, cables connected.
According to the plan, once they get out of the robot and get it on, should have about 11
I'll
minutes.
get the antenna as soon as we get
Then
there.
it'll be shut off, and they'll start off in the first traverse.
Roger, Dave, have at it.
First traverse takes about 26 minutes.
That's
They
how
will
long
stop
it'd
at
be
a
before somebody
checkpoint,
would show
but
that they
will
didn't
not turn
believe
on
they
the camera.
existed.
So there'll be a 26-minute lag before they
That's
get to
the
station
good
one.
time. That's
Yeah.
the
The
time.
Delbo crater. We've got 11 minutes. It's
Gentlemen, your discussion on various theories of the moon seems to be variations of theories that's going on for years.
I tell you, that
How
roller
long
is a pretty
can
picture
you
out there.
hopefully when can you hopefully expect to get some readout from this massive data that's been called up, and how many years or so?
I would say that
Harold, let me repeat the question, will you?
Stable, Joe.
The question can be summed up by saying that the discussion here at the table so far this morning has been a rehash, or perhaps an elaboration, or at least a discussion of several theories that have been in existence for quite a few years. When can the public expect to have the correct theory pointed out to them?
No, not the correct, but more definitive data at least.
The question then really is when can we sharpen up the question on which theory is more likely correct?
Well, I would say that I am wondering exactly the same thing scientifically. I keep watching for little bits of evidence that may occur, and I have no idea when something will turn up that I can say is definite. So far, I don't see anything that permits us to be definite about it.
The evolution of science is a rather interesting thing to watch.
Levity here in the control room. A duplicate of the instrumentation and communications officer INCO TV control panel has been placed on top of Chris Kraft's console with a card hanging below that says Cecil B. Decraft.
Roger.
FRC.
What I was trying to say a while ago is that science, like women, have fashions, and a theory that is widely held today, in fashion, so to speak, may be discarded a few years from now, only to be rediscovered still a few years hence from then. One of the best examples of this matter of fashions in science is that of continental drift. This can be traced all the way back to a fellow named Hopkins who worked around 1850. And he clearly, to his colleagues at least, demonstrated that convection occurred in the Earth, meaning material moves around, and the continents moved. Wegener later on in the early part of this century put together his ideas on the way continents fit together and how they moved around through the years, only to be rejected by most geologists.
And I'm configuring the geopalette now, Joe.
Okay, Jim.
And then just within the last 5 years, the matter of continental drift, which has now the respectable name of plate tectonics, is now back in fashion. I think most of us nowadays would certainly agree that the continents do move around. There are measurements of them moving, and so forth. I think this kind of parallelism carries through every branch of science, where ideas are brought forth, rejected, modified, rediscovered, and so on. And I think that will be the case for a long time with regard to the theories of the origin of the moon.
May I make a comment on that? I think this is more characteristic of geology and astronomy, for example, than it is of physics and chemistry. Physics and chemistry, we have the possibility of making experiments to test out a hypothesis, and hence decisions are made more rapidly. But geology, suppose you were going to give Nobel Prizes in geology. You couldn't do this. The man, Wegener's dead 50 years by the time we decide it's right. Do you see? An observational science that cannot make experiments has much more of this difficulty of going for long periods of time before it is generally accepted. And I think astronomy has much the same difficulty that geology has in this respect.
One of the things to remember is that we're not too sure yet about the origin of the Earth, although we've been doing quite a bit of experimenting at our leisure for a number of decades. I might say that my feeling is that the problem is really a single or a joint problem. The early days of the Earth are going to be tied up intimately, I think, with the early days of the Moon. And we've worked with this hunk of history that we have here for quite a while, and we're now having a chance to tap a whole new period of time, namely the time that's been wiped out on the surface of the Earth by weathering, erosion, and all the rest of it, but still is available on the Moon's surface. And we'll come closer. This isn't really answering the question, but we are coming closer to answering both of those questions at the same time. Where did the Earth come from? Where did the Moon come from? And incidentally, how did they get together?
What are the other possible theories besides capture?
Can I leave that to Dr. Urey?
Well,
Let me repeat the question. What are the other possible theories of the origin of the moon other than capture?
well, we might go back to Sir George Darwin, who suggested that the moon escaped from the Earth due to tidal action. This was dropped in probability considerably as a result of the work of Moulton and Sir Harold Jeffreys, who could find no mechanism by which this could occur. But it is revived again by Donald Wise in recent years, and John O'Keefe. I'm not convinced of this. I believe this is the least probable of all the methods. And then there is the matter of a moon forming in the neighborhood of the Earth. And there have been various ideas about that. The one that is most popularly accepted at the present time is a very high temperature origin proposed by Ringwood, in which the moon accumulated out of a vapor from a very hot Earth, and I think this is an exceedingly complicated process that has never been worked out in any detail, and I personally wouldn't know how to work it out in detail at all. It stumps me completely. And then there is the last one, the capture idea that the moon was formed somewhere else, and of course immediately the problem comes up is how did the moon get made somewhere else, and then how did it get captured by the Earth? Now, this specific theory has been put forward by Gerstenkorn in Germany, and Alfvén supports it, and they believe firmly in their ideas, as nearly as I can judge, that the the moon was captured by tidal effects. Gordon MacDonald and I threw off the suggestion that the moon was captured by the collision with objects in the neighborhood of the Earth, and this is only a suggestion. We can't prove it. But these are, in general, the ideas that are being talked about at the present time.
Harold, is there a Scientific American type article written on this that might be useful to these people?
Okay, Jim, and we assume
Oh, I don't recall any. I don't recall it.
Would you write one?
Oh, gee, don't ask me to write some more articles. I've got more writing to do than I can do now.
Actually, Dr. Urey wrote a very nice discussion of